My amateur radio friends VU24DX and VU2CPL are using automatic lightning detection and antenna disconnection systems. An automated lightning detection and antenna disconnection system is a critical line of defense for a Radio Shack, especially when dealing with massive capture areas of 80 meter or 160 meter wire antennas. These systems work by sensing atmospheric electrical changes and using electromechanical relays to isolate sensitive equipment like SDRs and linear amplifiers before a surge can induce destructive voltages on the feed line. Here is a breakdown of the technology powering these automatic safety systems. Detection, sensing the storm. Automated systems rely on specific sensors to detect the presence or approach of lightning. There are three primary methods used: radio frequency or electromagnetic pulse detection, example AS3935IC. Lightning strikes emit massive pulses of broad spectrum radio frequency energy. Specialized integrated circuits like the popular AS3935 Franklin lightning sensor listen specifically for these 500 kHz RF pulses. The IC analyzes the waveform of the EMP to distinguish it from man-made noise like fluorescent lights or appliance motors, and can estimate the distance to the storm front from up to 40 kilometers away. Electrostatic field mills. While RF sensors detect strikes that have already happened, field mills are predictive. They measure the ambient static electric field gradient in the atmosphere, measured in kilovolts per meter. As a thundercloud builds overhead, the local electric field spikes dramatically just before a strike occurs. If the field exceeds a safe threshold, the sensor triggers an alarm. Networked API data. Instead of local sensors, a shack computer can continuously poll weather networks like Blitzsortung or local meteorological APIs for real-time strike data in the immediate geographical area. Processing, the brain of the operation. Once a threat is detected, a microcontroller or single board computer acts as the logic center. A Raspberry Pi 5 or a simple Arduino can be programmed to monitor the output of AS3935 sensor or field mill. The logic typically involves a tiered warning system. Monitor mode. Storm is more than 20 km away. System logs data. Warning mode. Storm is less than 10 km away. The logic board sends a signal to drop the transmission release. Safe mode. Storm passes. A timer, often 30 minutes since the last detected strike, must expire before the system automatically reconnects the antennas. Disconnection, the actuators. When the microcontroller determines the antennas need to be isolated, it sends a control voltage to heavy-duty RF relays, high isolation coaxial relays. Standard relays are insufficient for RF applications. The system requires specialized coaxial relays or vacuum relays designed to maintain a 50 ohm impedance while offering high isolation between the contacts. Power handling. The relays must be rated to handle the station's transmit power without arcing. If you are running a 100 watt linear amplifier, the relay must comfortably handle that output under continuous duty. Grounding, the critical step. A proper automated disconnect does not simply open the circuit. If a relay just opens the center conductor, thousands of volts of induced static can easily arc across the tiny gap in the relay contacts. Instead, a proper protection relay is a single pole double throw SPDT switch that disconnects the antenna from the radio and simultaneously shorts both the center conductor and the shield directly to a heavy earth ground. Here is an interactive demo of automatic lightning protection system. You can see that it is now connected and the system status is monitoring. Relay state connected, timer 0. There are the options here: distant strike, nearby strike, imminent electromagnetic field, E field, electric field. Now for a distant strike, it is in monitoring mode only, and nearby strike, you see the relay has disconnected the system. The limitations of automation. It is important to understand the physics of a lightning strike. An average strike contains millions of volts and thousands of amperes. If an 80-meter dipole takes a direct hit, the energy will vaporize coaxial relays, jump across open contacts, and destroy the connected equipment. Automated systems are primarily designed to protect against induced voltages, the massive static charges, and electromagnetic pulse generated by nearby strikes that couple into the antenna. For absolute protection against a direct strike, a physical manual disconnection of the coaxial cables and moving them completely outside the shack remains the only foolproof method. However, for sudden unexpected storms, an automatic grounding relay paired with an RF sensing IC is an excellent safeguard for homebrew transceivers and digital hardware.